All right, ladies and gentlemen, welcome back. We're going to wrap up this chapter just talking about one question that a lot of kids have, and that's just how long does it really take to form a new species? Or how much difference really needs to be in place before we can look at them as two different, distinct organisms? And the question really becomes, well, it depends. Um, so when we see broad patterns in speciation, we can study them from the fossil record, morphological data, molecular data. Um, but just how quick, we know it takes time, but it really is a case-by-case basis. That being said, we can talk about some general patterns that we see. And so that's where these ideas of gradualism versus punctuated equilibrium come in. So Darwin was really one who was looking at evolution through the lens of this gradualism model, where species descend from some common ancestor and gradually get more and more different from each other in their morphology, or whatever the case might be in their characteristics over time as they acquire more and more unique adaptations based on the environmental conditions that they're living in. Fast forward almost 100 years before from Darwin to about the 1980s or so, and this idea of this punctuated equilibrium model showed up, where we've got these new bursts of change in species and then this relative stability over time. And that's what this idea is presenting, is that we get this branch point. Those species relatively quickly acquire a new set of characteristics that are beneficial to their environment. And then, so long as that environment remains stable, so do those species in terms of the characteristics that they have. New change in the environment and a new branch point from there. Really, the interval between speciation events can range anywhere from 4,000 to 40 million years if we look at just basic evidence from the fossil record, and we actually see an average of about 6.5 million years. But look at the range that you're getting there. So does that average really mean much? I don't know. Um, really does truly just drive dependence on how quickly the environment is changing. Are the organisms capable of adapting fast enough based on the way that they reproduce and their genetic structure? And what's the organism itself? You're going to see much quicker uh, evolution in things like bacteria or viruses than you will in a species like us as humans. And then the fundamental question of just how many genes have to change before we get a new species to form. And once again, the question really is, it depends. We see speciation that requires very few changes to maybe only a single change in their alleles to other organisms where it requires a lot. If you take a look at just these examples in some flowers, uh, one directional change in a spiraling of their shell affects the way that they mate, and that's all controlled by this single gene. I go to another organism, and two loci affect flower color that influences their pollination preference, and so that's what it took. Um, in other organisms, it may take many, many genetic changes, and so it really kind of drives the question of you need to study those individual species in the way that they evolved to really answer this question on a case by case basis.